Let f is a function defined from R to R such that f prime, f double prime are all continuous function with f greater than 0, f prime greater than 0 and f double prime greater than 0. Then limit of fx plus f prime x upon 2 when x is tending to minus infinity. So if we consider function f as e raised to the power x or exponential function, then we have f prime x equals to e raised to the power x, f double prime x is again e raised to the power x. All these are greater than 0. All these are greater than 0, whatever the value of x is coming from set of real number. Then e raised to the power x plus e raised to the power x divided by 2 is equals to e raised to the power x, and e raised to the power x goes to 0 when x is tending to minus infinity. So option C will be correct key. Let a belongs to R, the coefficient of x raised to the power 125 in the Maclaurin series of x plus a cube e raised to the power x is 28 upon factorial 124. We have to find value of a. Four suggestions we have to given, and we have to choose which one is correct option. As we know that e raised to the power x expansion of this one is 1 plus x square upon factorial 2 plus x cube upon factorial 3 and so on. If we multiply this one with x plus a cube, means in left hand side and right hand side what we have x plus a cube plus x plus a cube into x plus a cube x square upon factorial 2, and this one will go to as going. So we need to find x raised to the power 125, coefficient of x raised to the power 125. When we multiply x raised to the power 125, sorry 124 with x plus x a cube, then we will get x into x raised to the power 124 upon 124 factorial. This is term containing x raised to the power 125, and when we will multiply x plus a cube with x raised to the power 125, then this a cube multiply with x 125, x raised to the power 125, again we will get this term also, and the factorial is 125, and in this case factorial is 124 factorial. It is given that the coefficient, how to find coefficient, as we can write factorial 125 as 125 into 124 factorial. So x raised to the power 125 within bracket 125 plus a cube upon 124 factorial into 125, and coefficient of x raised to the power 125 means this one will be same as, means 125 plus a cube upon 125 into 124 factorial is same as 28 upon 124 factorial. It is given in the question. 124 factorial cancel out by this one. What we have? We have 125 plus a cube equals to 28 into 125. Now multiply these two. What we have? 125 into 28, we are getting 3500. This one equals to 125 plus a cube. Now find the value of a from this one, we will get a equals to 15. So which one option is giving value 15? Option B is correct. Let a be a sequence of real numbers such that a1 equals to 3 and an plus 1 equals to an square minus 2 times an plus 4 upon 2. If we consider sequence an is converging to L, then limit of an plus 1 is also L. So L equals to L square minus 2 times L plus 4 upon 2. What we have? 2L equals to L square minus 2L plus 4. This implies that L square minus 4L plus 4 equals to 0. L square minus 2L minus 2L plus 4 equals to 0. L take as a common. L minus 2 and minus 2. L minus 2 equals to 0. We have L minus 2 whole square equals to 0. This implies that L equals to 2. So limit of this sequence is 2. Option D is correct, and every convergent sequence is bounded. So option B is also correct. To find the value of limit n tends to infinity, summation 1 upon square root of n square plus k square. To solve this problem, we will use the concept of definite integral as a limit of sum. Definite integral as a limit of sum. Yes. So I can write limit n tends to infinity, summation running from 1 to n, 1 upon n into 1 upon within square root 1 plus k square upon n square. So you can use definite integral as replace 1 upon n as dx, k square upon n square as x, and limit will be from 0 to 1. I can write this expression as 0 to 1, 1 upon square root 1 plus x, 1 plus x square dx. And the formula of this integral is log x plus square root 1 plus x square, and take mod because of this is a log, and the limit is going from 0 to 1. Put upper limit. When we put upper limit, we have log 1 plus root 2, and whenever I put lower limit, it will be minus of log 0 plus 1, and value of log 1 is 0. So finally we will have log 1 plus, this is 1 plus root 2. Now check which one option is giving 1 plus root 2. Option B is correct. It is given that an and bn be two sequence of real numbers, and summation an square and summation bn square converges. Means series formed by these sequences square is converges. Then we have to tell about series a product of an and bn formed by product of an and bn. So what can we do for this? As series an square and series bn square converges, it means that their sum will also, means summation an square plus summation bn square, or I can write summation an square plus bn square, and their half means 1 upon 2. If I multiply by 1 upon 2, then it will also converges. We know that or you can understand this by a concept. It is okay, it is fine. Summation an square plus bn square converges, and we know that this is nothing but mean. This is mean, and algebraic mean and geometric mean. What is the relation? Summation sorry, square root of a n square into b n square is less than geometric mean, means a n square plus b n square upon 2. So their series, if it is convergent, then this one also, and this one implying that summation a n b n, hence this is convergent. Now check which one option is giving the value convergent. Converges to 0 is always convergent, but not converges absolutely. Always convergent, but not converges absolutely. So may not converge. Option B is directly discarded. Converges to 0, it is not necessary. That's why option D. Now if these are positive term series, then converges absolutely also. So option C has been discarded. Now remaining one is true because of this question is based on the MCQ pattern. That's why option A is correct. Otherwise summation a and bn is converges, not absolutely. Converges. Absolute convergence implies convergent, but convergent doesn't imply absolute convergent. But in this problem, all other options has been discarded. That's why option A is true. Which of the following matrices is similar to given matrix? Similar matrices have same characteristic polynomial. That's why same eigenvalues. Same eigenvalues, it means the same trace and the same determinant. Trace of given matrix is equals to 4 and determinant of this matrix is 0. Now in suggestions, which one is giving you determinant? Sorry, determinant is 3. Giving you determinant 3. So option A having the determinant 3, option B having the determinant equals to minus 6, option C having the determinant minus 4, and in option D determinant of given matrix is 9. So which one is giving determinant 3? Option A. That's why it is correct. Which of the following matrices is diagonalizable over R? If matrix we have to find is diagonalizable over R, this matrix A is not symmetric. Option B not symmetric. Sorry, option B is symmetric, but option A is not symmetric. Option C is not symmetric, and option D is not symmetric. We know the concept of symmetric matrices always diagonalizable. Real symmetric matrices always diagonalizable. That's why option B is correct.
The value of this limit is square root of x minus y minus 2 upon within bracket x minus y minus 4. Whenever you are getting a square root, always try to rationalize the given function. So square root of x minus y plus 2 upon square root of x minus y plus 2. The numerator part we have x minus y minus 4 upon x minus y minus 4 into square root of x minus y plus 2. So this one is cancelled out by this one. We have 1 upon square root of x minus y plus 2, and xy is tending to point 2 minus 2. Now put these value, what we have, 1 upon square root 2 minus minus plus plus 2. So 1 upon 2 plus 2 becomes 1 upon 4. Option B is correct.
Let f is a function defined from R to R. be a twice differentiable function if another function g of two variable x and y is f x square minus y square, then need to find gxx plus gyy. First, integrate this function g with respect to x. We have 2x f of x square minus y square. Now integrate again with respect to x. We will have 2 outside x f x square minus y square into 2x plus f of x square minus y square into 1. So this is our gxx. Now find gy. Gy will be, or gyy will be 2 times, what will be gy? First try to find gy. Gy will be minus 2y f of x square minus y square. Now gyy, it will be minus 2y in, into f of, sorry, f dash and f double dash, f dash. This is f dash. So minus 2y into f dash dash or f double prime x square minus y square into minus of 2y plus f dash x square minus y square into 1. Finally, what we have, gxx plus gyy equals to 2x f double dash x square minus y square into 2x plus 2f prime x square minus y square minus 2y f double prime x square minus y square into minus 2y plus 2 times f prime x square minus y square. From these two, this minus and this minus turns to positive, and what we have, now this is minus, it will cancel out because of this will give you negative sign. We have 4 outside x f double prime x square minus y square, or you can take x square plus y square f double prime x square minus y square. You can take f double prime same as common, so x square plus y square for outside into f double prime x square minus y square. Which one option is giving this information for x square plus y square f double prime? Option B is correct. The number of elements of order 15 in the additive group Z30. We are seeking number of elements of order 15 in Z30. For this problem, we first recall the general rule how to find number of elements of a specific order. Suppose we are seeking of order k in Zn. First condition is k must divide n. If k divides n, the number of elements of order k will be 5k. If k doesn't divide n, the number of elements of order k will be concept, I can write 15 as 3 into 5. Now apply Euler 5 function 5 over 15. So 5 3 into 5, this is equals to 5 3 into 5 5. This one equals to 2 into 4 equals to 8. Option C is correct. How I used Euler 5 function? If 5 pq equals to 5p into 5q, whenever GCD of pq is 1 and 5p equals to p minus 1. Used these two concepts to evaluate the value of 515. For the group G, H and K, with H being a proper subgroup of G and K being a proper subgroup of H, where order of G equals to 380, order of K equals to 38, the possible order of H are. For a group G, H and K, these are proper subgroup of G, and these are subgroup in such a manner H is a proper subgroup of K and K is proper subgroup of G. By Lagrange's theorem, we know that K is proper subgroup of H and H is proper subgroup of G. That's why by Lagrange's theorem, we know that order of subgroup always divides order of group. It means that order of K will divide order of H and order of H will divide order of G. Order of G is 380. So order of K will divide order of H and order of H will divide 380. So we can write 380 as 38 into 10 and order of K divides order of H divides this. So if I use these two, because of K is proper subgroup of H, means the order of K will divide order of H. So order of H will be order of K into n times. Value of n is some positive natural number. Order of K is 38. That's why 38 into n. Now we have order of H. And order of H divides order of G by Lagrange's theorem. We have 38 into n will divide order of G, which is equals to 38 into 10, because of you can write 380 as 38 into 10. So 38 cancel out by 38. We have n in n divides 10. So possible value of n is either 2 or 5. So order of H will be 38 into n, where value of n is 2 or 5. When n equals to 2, then order of H will be 38 into 2 means 76. When n equals to 5, then order of H will be 38 into 5 equals to 190. Now which one option is giving this result? Option A is correct. The Wronskian of the function y1 equals to x square and second function y2 equals to x mod x at x is. You can write this mod function as y2 equals to x into x when x is positive or greater than equals to 0, and y2 equals to x into minus x when x less than 0. You can write further minus x square. So when x is positive, when x is greater than equals to 0, in this case the Wronskian can be written as y1, y2 and their respective derivatives. So put in these for quantity in a determinant, and you have x square 2x 2x. You can observe this value is equals to 0. 2x cube minus 2x cube equals to 0. Now which one option is giving
you value 0. So option B might be true and option A and C has been discarded at this position. Now, when x is less than 0, when x less than 0, you will have y1, y2 and their respective derivatives. Put these in determinant structure. You will have x square minus x square, 2x minus 2x, and the value of this determinant equals to minus 2x cube plus 2x cube, and this value is again 0. So now we are confirmed option B is correct.